I want to show the addition of 5/4 plus 2/5. In order to add fractions, we must first define our whole. We need to show both fractions in the same size whole so that way we can add them, we can combine them. We want to think about addition just with fractions just like we do addition with whole numbers. We literally want to just put these two pieces together and then find out how much we have in total, in sum. So let's see what this looks like with the Cuisenaire rods. Here is my virtual manipulative of the Cuisenaire rods, and I'm going to turn on the labels here so that way you can see how much each of these is worth. So in order to define this whole, I have to find one whole that can show both fourths and fifths. I can reason about these numbers thinking about an array of a 4x5 array that would show both fourths and fifths, and use that to apply to the Cuisenaire rods. If I had 4 yellow rods that are each length 5, I could also do 5 purple rods that are each length 4. This again connects and relates back to our set model. When we create a whole that shows both fourths and fifths, we create a 4x5 array, and it could be a 5x4 array representing the commutative property. Here we can see that as well. 4 groups of 5 or 5 purples, 5 groups of 4. Thus I know my whole is going to be defined as 2 tens, or a whole of 20 of the unit cubes. So I know that my purple rod is a fifth. My yellow rod is a fourth. It's the opposite of the label, and that's where maybe turning the labels off could help us. 1/5, because there's 5 purples that make up the whole, 1/4. And now I want to show 5/4 plus 2/5. 1, 2, 3, 4, 5 plus 2/5. If this was long enough, I'd keep going, but I'm going to start down here, and maybe actually I'll move this one down here. Now we see, I'm going to turn the numbers back on. We have one whole plus 5 plus 4 plus 4. 8 plus 5, 13. Right? We're comparing lengths, so we have one whole and 13 twentieths. We didn't have to do any multiplication. We didn't have to find equivalent fractions to start. We didn't have to even talk about these as a common denominator before we added them. We used the models to help us figure out how much we had at the end. Once we defined our whole, then we could use the notion of 1, 2, 3, 4, 5/4 plus 2/5. I'm going to move these out of the way. And then once we figured out our sum here, put these all together. Once we figured out this sum here, now we know that that is 1 whole and 13 twentieths.